So this quiz is going to look identical to what I'm doing here, except for the fact that the numbers are just different, okay? The style of the problem, the look of the problem, the stuff that I ask you to do with the problems are exactly the same, except the numbers are just different numbers, okay? So you can't just sit there and just memorize. It'd be very difficult to just sit and memorize the answers anyway, even if you knew all the answers. Probably be harder to do that than it would to know how to do the problem, to tell you the truth. All right, here we go. Ready? Number 1. It says find the central angle. Find the central angle of a regular decagon. Now, on the quiz tomorrow, it's not going to be a decagon. I'm going to tell you right now. But you're going to do the problem very similar. You got to know your shapes, okay? Your polygons, all right? So decagon is how many sides? Decade, how many years? 10 years, okay? Deca is 10. What's a 8-sided figure? Octagon. What's a hexagon? What's a pentagon? Okay, you got it? Okay, so know those words, okay, because that's what I'm going to do. It will not be a decagon tomorrow, all right, but it's going to be one of the ones that you just talked about. So how do I find the central angle of it? Now, you do not, I'm going to draw it for you because I can, with this computer program, I can do it pretty quickly. You do not have to draw it if you understand what you're trying to find. You should be able to do this, or at least write out the little formula fairly easily. All right. So it says find the central angle. Central angle, what does that mean? It means it goes from the center to the vertices. Everybody see that? So that would be one central angle. I could draw how many central angles here? 10, because there's 10 sides. That's right. So I could draw 10 of them, all right? But I just want to find one of them. If I went all the way around, if I started here and went all the way around, how many degrees is that? 360. But I don't want to find all the way around. I just want to find from here to here. So how do I do that? I take 360 and do what to it? Divide it by 10. That's it, okay? It's that simple. You don't have to draw it, all right? I mean, that would take too long to draw a decagon, wouldn't it? A regular decagon. It would just take half the quiz to do that. You just have to understand that if I drew a central angle, that angle is 360 divided by how many sides that I have. Okay, decagon's got 10 sides, so there you go. And then this is easy math. If you couldn't do the math, you could put it into a calculator, but this is super easy. The zeros cancel. What am I left with? 36 degrees. So that means that this angle right there is 36 degrees. That's the central angle. Okay? Easy. Everybody's got the first one right, correct? Again, it's not going to be a decagon. What if it was a, I don't know, give me a shape. What'd you say? Hectagon? I don't think we said hectagon. I don't think that was one of our things. Hexagon. Hexagon, all right? So what would you do if it was a hexagon? You do what?
360 divided by 8.
Well, you might, but I wouldn't. 360 divided by what? What's hexagon? It's 6, all right? You said 8. What is an 8-sided figure? It's an octagon. So what if I said a regular octagon? What would you do? 360 divided by 8. You see how easy that is? Okay. All right. All right. Number 2. Well, 2, 3, and 4 are all kind of the same. I'm just going to do one of them. Yeah, I'm just going to do one of them. And they give you pictures. The first one's a triangle. And they do draw the picture for you, okay? So you don't have to draw it or anything. They give you this. It's an equilateral or a regular triangle, I guess, if you want to call it that. Let's put the center right there. And here's what they give you. And they make this as easy. Me. I'm the one that made the quiz, right? I made it as easy. Well, I probably got it from the book somewhere. All right, I made it as easy as I possibly could. They give you this, they say this is 5 right there, and they give you this, 15.7. This is all in feet. This is in feet as well, okay? And they ask you to find the area of this triangle. Well, the old-fashioned way, it's not really an old-fashioned way, it just depends on what they give you, but what we first learned on how to find the area of a triangle was base times height divided by 2. Problem is, I don't know the height of this thing. And like from here to here is not necessarily the same distance as from here to here, all right? Why are phones ringing? Turn it off. Turn it off. Like, shut it completely down. Not just the sound, but completely shut it down. So do you remember what the formula was? If you have a regular polygon, to find the area of it? No, it's 1/2.
Wait, to find the area, that's the
This is in section 7.5. Not yet. I'm in the middle of, I'm asking you what it is. What's the area of a regular polygon? It's 1/2. What's this little thing right here? It's the apothem. So what am I going to do here? 1/2 times the apothem. Whoops, let's write that bigger. Times the apothem times the what? Perimeter times the perimeter. Why is Mario the only one that remembers any of this stuff? All right, that's our formula. You got to know it. You got to memorize it. All right, quiz is tomorrow. I'm writing it down right now. I'm telling you, you got to know it, so know it. That's all I can do. There's no special trick that I can do to help you memorize this. Well, there's 2 A's. The first one is area. This one is apothem. This is the apothem. The apothem is from the center perpendicular to one of the sides. That's the apothem. So it's almost all given to you, except for one little thing, the perimeter. So let's write it down. So what's the area? It's 1/2 times the apothem. They give you the apothem, so that's nice. So it's times 5 times the perimeter. It's not just 15.7, it's 15.7 what? Times 3, right, because this is 15.7, so is this, and so is this. All right, to find the perimeter, you take one of them, multiply them by 3. Again, it's a regular polygon, which means all the sides are equal to each other. All right, so if they give you one side, that means the other sides are exactly the same. Now, what do I do with this thing right here? Do I just circle it and leave that as my answer? What do you mean solve it? How do I solve for that? Use a calculator, exactly right. Use a calculator and you get, I got anyway, 117.8. This is feet, so it says area, so it's what? Feet squared. Area is always squared. Okay? Number 3 and number 4 are pretty much just like this. They give you the apothem, they give you one of the sides, and you just do the same exact thing. It's just a different shape. It's not a triangle, all right? So 3 is a octagon, so that's an 8-sided figure, 8 sides. And then number 4 is a square, so it's 4 sides. Okay? But you do the same thing. They give you the apothem, they give you this, and they give you one of the sides. Actually, on number 4, they don't give you one of the sides. I'll give you a little hint on number 4. I didn't do this for the other class. So watch this. Let's do it in red, since we've been doing apothem in red. This technically is the apothem, but that's all they tell you. The only thing they tell you on this one is the apothem. But since it's a square, that's right. Because look, from here to here is 6. What would it be from here to here? 6. So from here, watch, you watching the pointer? From here all the way to there would be what? Would be 12. So that's one of the sides, isn't it? Okay, so how do I find the area of this thing? You could go 1/2 the apothem times the perimeter. But what would be even easier? If this is 12, you know it's a square, so this is 12. So what is it? How do I find the area? 12 times what? Are we on the same page here? I don't know if we are or not. Look, if this is 12 and this is 12, what do? Just, the area of a square is just length times width, right? Base times height. 12 times 12, which is what? 144, okay? Let's do the 1/2 the apothem times the perimeter thing. 1/2. What would I consider to be the apothem to this? 6. Right, this would be the apothem. Times the perimeter. What would the perimeter be? 12 times. Not 12 times 12. How many 12s are there? There's 4 of them. So it'd be 12 times 4. Right? Let's see what we get. We can do this in our head, can't we? Can you? I don't know. What's half of 6? 3. What's 3 times 4? 12. So 12. So it still comes out to 12 times 12, doesn't it? Which is still 144. So I can actually do this a couple different ways. Does that make sense? Well, they didn't give it to you. We figured this out. They didn't give you that. We figured that out. The only thing they gave you was this. That was the only thing they told you. All right? As far as numbers are concerned, they told you it was a regular polygon, which means all the sides are equal, right? So if this is 6, then from here to here, you having a fit or what? You need to go to the nurse? So watch. If this is 6, then this is 6. That means this whole thing is 12, which means up here is 12. Since it's a square, a regular polygon, all 4 sides are 12, right? So I could have just said, well, the area of a square, do you remember this, is equal to sides squared, or the area is base times height, or the area is length times width, right? All those give you the same thing, don't they? Okay, what's another formula? Area is 1/2 the apothem times the perimeter. You put it into any of these, and you're always going to get 144 every single time in this particular problem. Now, that only works when it's a square, okay? But that's how you do it. All right, we spent way too much time on that. Hope the other class can figure that out. No, because it's got to be a regular polygon. A rectangle is not a regular polygon, right? So that 1/2 times the apothem does not work for something like that because it's not regular. What does it mean to be regular? It means all the sides are equal and all the angles are equal. On this, all the angles are equal, but are all the sides equal with that? No. So you're not going to use the 1/2 times the apothem times the perimeter on that rectangle. All right, enough of that. Number 5. Let's see. 1, 2, 3, 4, 5. Pentagon. No, 6. I can't count. I didn't think we were going to do a pentagon. All right. So here's 6-sided, regular polygon. So it's a hexagon, correct? Now this one takes a little bit more thought. So I hope you're paying attention, you're not goofing around. Because it seems like a couple of you are just making a joke out of this. And the ones not making a joke out of this aren't even paying attention to me. So let's take a look. They do this for you. Remember that first problem? What was the first problem we did today? Central angle, right, finding the central angle. So that's going to come into play here, right? That's why they ask you on number 1 to find the central angle, because you're going to have to be able to do it on this problem right here. Okay, they give you that as 6, and that's all they give you. All they give you is one of the sides. That's the only thing. They don't give you any angles. They don't give you the apothem. They give you nothing except one of the sides. But we're going to be able to figure it out with just given that right there. You also know it's a regular hexagon. That's very important. So what we're going to do is this. They don't do this on the quiz, or they don't draw this. Actually, they do. They put a dotted line. Instead of a red line, they put a dotted line right there. Okay? All right. And let me go back to white. All right. So this is what they give you. Now, they put the line there, but they don't tell you how long that line is. What is that line? What is that red line? I did it in red because I did it before in red. It's the apothem, right? So what do I need to do? I need to find, well, I know what 1/2 is. I got to find the apothem, and I can find the perimeter pretty easy, can't I? Just 6 times 6, okay? It's the apothem. That's the thing that I need to find, okay? So how in the world do I find that? Well, look what I did. I made it into a right triangle, didn't I? By the way, what's this from here to here going to be? That's going to be 3. Okay? Now, what do I need to find? I need to find this length right here, don't I? How in the world am I going to do that? Well, I need to know something, okay? We talked about a couple special triangles in this chapter. We talked about 45, 45, 90, talked about 30, 60, 90. So remember what I said earlier on number 1, you had to find the central angle? That's exactly what we're going to do right here. Let's find that central angle. Now, there's 6 angles, 6 sides, so how do I find the central angle? 360 divided by 6. Good. What does that give us? 60 degrees. So that big angle is 60 degrees right there. But that's helpful, okay? But really what I want to do is I want to find that angle right there. What's that angle going to be? That's going to be 30. So if that's 30, what's this one down here? That's 60. So I got a 30, 60, 90 triangle. Now we know stuff about a 30, 60, 90 triangle, okay? Remember this? That the long side is equal to the square root of 3 times the what? Times the short side. That's something, again, that we learned in this chapter. You had a quiz on it, all right? You're gonna have to know this on a test when we take the test on this chapter, probably next week. All right, so you got to know that the long side is the square root of 3 times the short side. Do you remember that? And the hypotenuse, you're not really going to have to use this one, okay? But what is the hypotenuse? It's twice the short side, the short leg. So that's something that I expect you to remember. We went over it. We had a quiz on it. All right, you got to know it. How does that help me with the apothem? The apothem is my long side, isn't it? Okay, because it's opposite the 60, so it's the long side. So, because I found out that I did all this. I found out that the whole central angle was 60. Half of 60 is 30. And I know this is 60 because it's a 30, 60, 90, right? Because 90 minus 30 is 60. All right, so it's a 30, 60, 90 triangle. And this is why I cared that it was a 30, 60, 90 triangle. That's what I wanted to use. So A is my apothem. That's the long side. So the apothem is what? The square root of 3 times the short leg. What's the short leg on this right triangle? It's 3 times 3. So I'm going to write it like this. 3 times the square root of 3. So check it out. I needed to find the apothem. I just found the apothem, didn't I? All right. Now, to find the area shouldn't be that hard. Finding the apothem was the hardest part. Once I found the apothem, the rest is easy. So it's 1/2 times the apothem. What's the apothem? 3 square root of 3 times the perimeter. How do I find the perimeter? 6 times what? 6, right. There's 6 sides. Each side is 6. Now, what do I do with all this stuff? Throw it into a calculator. And once I throw it into a calculator, I should get 93.5. You need to practice that. All right, this is all in meters. I never said that. So this is meters squared. So that is your area of that whole entire hexagon. Everybody got me on that? So the square root of 3, you need to know how to put a square root of 3 into your calculator. You don't normally do that. All right? For some calculators, you hit the 3 button first, and then you hit the square root button. Okay? In some calculators, you hit the square root button first, and then you hit what? 3. You have to know which calculator yours does, or how your calculator works. Okay? Is your calculator the one that goes 3 then square root, or is it square root, then a 3? You need to practice it. Okay, you need to know how it works. Go ahead. You don't even have to put times. On a calculator like this, you don't have to. And it's same thing with this. Yeah, because they're not being times. They're not being multiplied together. You're just finding the square root of that number. 3 and then square root. See, a calculator like the one on my phone, I have a scientific calculator, and some of you guys might have a calculator that looks very similar to this. Everybody see that? Okay, do you have a calculator that kind of looks like that? All right, if you have one like that, not all the time, it all depends. Okay? Even Texas Instrument, used to be Texas Instrument, you'd always hit 3, then the square root. But there's some Texas Instrument calculators, depending on the model, that you would hit the square root first, okay, right here, and then you would hit the 3. So you have to know. So do you have your calculator with you? You should. You should always have it with you in your math class. You definitely need it tomorrow. If you don't have your calculator tomorrow, I can guarantee you probably will only get one right. It's probably the first one. Okay? So if you don't have your calculator and you don't know how to use your calculator, you'll probably only get one problem right, would be my guess. So calculator is a necessity on the quiz tomorrow. You got it? And you cannot borrow somebody's calculator during the quiz. You must have your own. Now, if you borrow from somebody in another class, I don't care, all right, as long as you have your own calculator. You got it? I can't stress this enough, because if you come to me, I am not going to, and don't come to me and say, can I go to Cheadle's class and use one of his calculators once class has already started? No. Once class has started, you come in, you need to have it. If you want to borrow from Cheadle before you come in here, it's up to you, all right? But walking in that door, you must have your own calculator, and you must only be using your own calculator. You got it? Okay. So on this calculator, you hit 3, then you hit square root, and it gives you an answer, 1.73, blah, 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 a whole bunch of other numbers, right? But on some calculators, like this one right here, you would do this. You'd hit square root first. Where is the square root on this calculator? It's right here, and it's in yellow. It's not actually one of the buttons. It's actually behind the button. You see it? So how do I make that yellow button work? Hit the second function, and then I hit that. See it? Okay, so some calculators do it like this. You need to know how your calculator works. So you hit square root, and I'll just hit 3, close it. You don't really have to close it, but I like to close that parentheses. Then you hit equals. There it is, 1.73, just like it was on my calculator. Okay? You cannot use your phone as a calculator. All right? You cannot use your phone. Now, at home you can, but not on a quiz in here. Go ahead. Oh, like right here? No, these are being multiplied. This 3 is being multiplied by this. Well, on this calculator, you would go 3, and then you'd hit square root. Oops, what did I do? Let's try it again. Oh, I know what it's doing. I would hit square root of 3 first, okay? So I would hit square root of 3, so square root of 3, all right, and then times 3. Okay, that's how, on this calculator, that's what you should do, okay? I really thought when we were doing this thing, you guys would be whipping out your calculators and testing this. All right? That's what you should be doing. All right? Don't you carry your calculator in your book bag? I mean, you got tons of pockets. All right? You should be carrying it. You should have tried this on your own. Okay, enough of that. All right, let's keep going. I'm running out of time already. So that was number 5. This is number 6. Circumference. We kind of went over that on the homework, right? That we went over a little bit. So what's the formula for circumference? We talked about it a few minutes ago. It's 2 pi. Just stop. Okay, it's not funny. Nobody cares. It's 2 pi r. Okay, the circumference is 2 pi r. So this is very easy. On number 6, they give you the radius. They don't give you a picture. They just give it to you in words. They say the radius is 10 inches. Okay, and they ask you to find the circumference. So how do we find the circumference? It's 2 pi, and then r. What's the r? It's 10. Now, don't use the pi button on the calculator. A lot of calculators, almost all of them, have a pi button on there. Okay, don't use that. What are you using? You're using what? 3.14. Okay? So you're putting all that into your calculator. Everybody got that? And that'll give you 62.8 if you want to try that yourself. This is in inches. Is it inches squared? No, because it's circumference. Circumference is just a distance. It's not an area. All right, so you just put inches. You don't put inches squared. Now, number 7, they do ask for the area. And it's the same problem, all right, but they ask for the area of it. So what's the formula for area of a circle? Pi? No. Pi 2r, that's the circumference. It's written right here. Okay, the area is pi r squared. That is not a 2. I know it looks like a 2 to you, but it's not. It's a what? It's a squared. Okay, squaring something and multiplying it by 2 are completely different things. So the radius, they give you this, actually they put it in feet, at least in this problem. But the number is going to be this, well, the number 10 is going to be the same. So how do I find it? So pi, which is what? 3.14 times the radius, which is what? 10. And what are you going to do that radius? No, you square it. You square it. Technically, yes, multiply because you're going 10 times 10, but I want you to say square it. You could actually do this one in your head. Did you realize that? Because watch, it's 3.14 times what? What's 10 squared? It's 100. Can you multiply that by 100 in your head? Yeah, you take that decimal, you move it where? To the right. You're making it bigger. You're not making it smaller. You're multiplying by 100. So you move it to the right, which gives you what? 314. This is in feet. This time it is area. So it's feet what? Feet squared. So that's how you would do that. All right. 8, 9, and 10 is what I want to take. We got 10 minutes. I only had 5 minutes in the last class, and I was able to finish it. Let's get rid of this calculator. Okay. All right, so let's draw a circle. It's drawn for you, okay, so you don't have to worry about drawing it yourself. And I'm going to put a couple things in here. So they do this. They go to there, and they go to there. All right, the first question is going to be to find the area of the sector. Now, they do put letters here. They say find the area of sector PQR. What is that? There's P, there's Q, there's R. So what are they asking to find the area of? Right. Now, they don't shade it on the quiz. They just say sector PQR. So you got to know what they're talking about, okay? They're talking about that right there. So we got to find the area of that, which is really not that difficult. They do tell you an angle. They tell you this angle, the central angle is 78 degrees, okay? So how do I find the area, that shaded region? We just did this yesterday. That was the first time we did it, was yesterday. Okay, so it should be fresh in your mind. Maybe. What do? We're just finding a part of the circle, right? We're not finding the whole circle. We're just finding a portion of the circle. You got it. It's 78 degrees out of what? 360. So that's the part of the circle we're trying to find. And we're finding the area. So what do we put next? Pi r squared. Now they do tell you the radius. I forgot to put that in there. Sorry. It's 3. Everybody see that? So really, that's the only thing you really needed to know about the sector. The rest of it is just thrown into a calculator. Agreed? So it's 78 over 360 times pi, which is 3.14. And then the radius squared. What's the radius here? It's 3, and we're going to square it. So now, what do we do with all this mess right here? Put it into a calculator. Okay? Once you put it into a calculator, you get 6.1. All right, 6.1. This is in centimeters. I didn't say that. So this is centimeters what? Squared. So that's the area of that sector. You with me? All right. Make sure you practice this, okay? It's on the, if you're not taking notes, well, you should be, but if you're not, watch this on the video. When you get home and you get your calculator, punch that into a calculator and make sure you get this as an answer. All right? You got to make sure that you're, because this can be a little bit complicated on a calculator. This is what I would do. I would go 78 divided by 360 times 3.14 times, you can just do this in your head. What's 3 squared in your head? It's just 9, right? Just put a 9 in there. Put all that in your calculator, and then you should get 6.1. You need to practice that. Everybody hear me? You may hear me. I don't know if you're really listening. All right? I hope you are. I hope you are. All right. Enough of that. So that's the area. I'm just trying to get this out of the way. Let's move all this. Get rid of that. Let's put this here, right there. Okay, so that's the sector. Everybody good? Now they're going to ask you to find something else. What else did we talk about yesterday? Find the sector and the segment. Very good. So where is the segment? It's from P to R. Now you're not finding the area of a straight line like this. Okay, you're finding the area of this little bit right here. Everybody see that? Remember this from yesterday, right? What's that? I don't know. It doesn't matter. It's 8, 9, and 10. They're actually in a different order, but they all go together. And they actually asked you a separate question to find the area of the triangle. Okay, so they will ask you to find the area of the triangle. Let's do that first. Okay, so the area of the triangle. All right, how do I find that? Base times height divided by 2, correct? Okay, now we don't know that that is a, well, we do know that it's not a equilateral triangle because that's 78 degrees. If it was equilateral, if it was a regular triangle, it'd be 60, 60, and 60. Okay, but it's not. All right, so what am I going to do? I'm going to put the height in here. Where is the height? It's from here, perpendicular. Let's see, does that look perpendicular? Yep. Perpendicular to there. So that is the height. Okay? They tell you one more thing I didn't write in here. They tell you that line from P to R. Let's make that a different color. Oops. Should have clicked on it first. Let's make that a different color. They tell you that blue one right there, that whole entire blue one is 4. Okay? But what do we care about? Here's a right triangle, correct? I need to find the height. So what is that little blue one from here to here? That's going to be 2. Agree? Because from P to R is 4, because this thing does what? It splits it in the middle, right? Splits this angle, okay, and it splits this side. Because they told me it was 4. Okay, they told me that was 4. So what did I figure out? I figured out that this was 2. So now I got to find the height. What is it? Pythagorean theorem. It's a right triangle. You see this right triangle right here? It's Pythagorean theorem. So it's going to be h squared plus what? Give me numbers. I got numbers here. Okay, plus 2 squared equals what? Hypotenuse squared, which is 3 squared. So this is how you need to write it out to solve for h. Now I can solve for h, can't I? Look, h squared plus 4 equals 9. Subtract 4 from both sides, so h squared equals 5. Take the square root. H is the square root of 5. So that's what the height is. Why did I need that? Because I need to find the area of the triangle. What's the area of a triangle? It's base times height divided by 2. What's the base of this triangle right here? The whole entire triangle. What's this whole entire triangle? The base of it. It's 4. It's 4. 78's an angle. That's not the base. This right here is the base. That's 4. Because if this is the height, this is the base. So the base is 4 times the height. What's the height? We just found it. It's not a 5. It's a square root of 5 divided by 2. Put that into a calculator, and you get 4.5. And that's centimeters squared as well. Now watch this. Remember that shaded area, that segment? That's what we really want to find. Now it's super easy. It's just basic arithmetic right now. Now listen to what we just did. We found the whole entire sector, didn't we? And then we found the triangle. This is what's left over. The whole entire sector was 6.1. The triangle was 4.5. How do I find what's left over? I just subtract. That's all I do. See it? Okay, I found the whole sector, right? From here to here, around the curve, back up to here again. I found that whole thing, and I got 6.1 for that. And then I just finished finding that triangle. If I take that triangle away from that whole entire sector, what am I left with? That shaded in part, which is the segment. And so, what's my last step? Just 6.1 minus 4.5. And that comes out to be 1.6. And that's the area of the segment. Is 1.6. It's in centimeters, so it's what? Centimeters squared. So this is my triangle, right? That's the sector. So I take the triangle away from the sector, and I am left with the segment, what's left over. Well, study it. Practice it. Okay, you got to practice it. The hardest part was just finding the height. Okay, it's just doing Pythagorean theorem. The Pythagorean theorem is really not that hard. You just have to understand that that's what you needed to use. And you will use it on the quiz. All right, there'll be different numbers. This is not going to be a 3. That's not going to be a 4. It's going to be something else. But you're going to, and that may not be a 78. All right? But that's what you're going to do here. All right, it's on video. So my suggestion is you watch it. You don't just sit there, hit play, and then just sit there blind, just in a daze listening to it. Okay, just go to the part right here where you were unclear about it. Right, sit and write it down. Don't just sit there and watch it. Be interactive. Write it down. All right, try it on your own. All right, watch the video, get some hints, then try it on your own without any hints whatsoever. And when you can do that, then you're ready to take the quiz. If you can't do that on your own, you're not ready for the quiz. Please bring a calculator tomorrow. All right, and bring your own calculator. If you do not bring a calculator, you are not going to borrow mine. You're not going to borrow anybody else's. You're not going to leave the room and borrow. All right, bring your own calculator. Have I said that enough today? I'm sick and tired of saying it. All right.